In this video, we will continue to look at this little puzzle, but also we gotta continue and we're gonna be talking about specifically the distal convoluted tubule of the nephron. So here we have the nephron. We've already talked about the glomerulus, the proximal convoluted tubule, the loop of Hennell, and now we get to this one, the distal convoluted tubule. First of all, why is it called the distal convoluted tubule? Distal because that means far away. So we know the nephron starts here. So we know this is the proximal convoluted tubule because it's close to the beginning of the nephron. This one is real far away. You have to go first all this pathway before we get here. So it's called distal because it's far away. And convoluted because we know convoluted means squiggly or wiggly or odd in shape. Okay, so this is the distal odd in shape tubule because it's far away, it's odd in shape. Okay, so that's why it's called distal convoluted tubule. Now, I must say, the distal convoluted tubule for the IB, there's not much you need to know, so it's fairly straightforward. So before we get to this one again, let's just real quick recap what happened here, okay, because it's important. So we know our blood arrives at the kidney to be filtered, right? We know this is an ultimate filtering machine. Now we have some good and bad things in our blood entering this nephron here. Okay, now we know that this first part sorts our blood by size. Okay, so all the small things will pass through, all the big things won't be able to, and they will stay in the arterial and come around here and stay in our bloodstream. Okay, now we know these things that were filtered were both good and bad because these small things could be good or bad. This system did not separate by good or bad, only by size. So up till the proximal convoluted tubule, we have good and bad things. So logically, we know this is the ultimate filtering machine, meaning it should be good. Therefore, in the proximal convoluted tubule, it will take out all the good things and put it back into our blood. So going from here to here and keep the bad things inside this tubule, okay? Because we want it to leave our body. Anything that stays throughout this whole system inside will leave our body through our pee, okay? So that's cool. Now we have some things, some nutrients, some water, and some other things left in this tubule still, and it comes here to the loop of Hennell. The loop of Hennell is the most complicated part of this one, and I made a video on it, but just for now, know that it doesn't really absorb things into our bloodstream. More its purpose is to make a concentration gradient, meaning it is responsible for making sure that from here to here, it increases in concentration gradient, meaning it's the least concentrated here and the most concentrated down here. And this is super important for what's going to happen in the collecting tubule, and we'll talk about that later. So if you don't quite get this, just go check out my video, and I'll also clear it up tomorrow when I talk about the collecting duct. Now, at this point, we have everything leave the loop of Hennell into this distal convoluted tubule. So we still have a lot of water, but mainly we have bad things, okay? Because all the good things were kind of put back into our blood, okay? So it's pretty much only bad things left. And notice how this arteriole follows along the nephron all the way. And that's important because whatever gets removed from this tubule must go somewhere. And so it's important that the arteriole follows because it's going to go into the arteriole. Otherwise, it'd just be lying around randomly. Okay? Now, let's get to the distal tubule. It's real simple, as I mentioned. So here we have the distal tubule, this whole one, and we have the blood, okay? The bloodstream. And here we have the distal tubule contents are flowing in this direction, okay? So in the distal tubule, we have, as I mentioned, a bunch of ions, okay? So we have sodium, chlorine, calcium. And the purpose of this distal tubule is to absorb, as you can see by this arrow, all the most of these ions into the bloodstream. So just like that. Okay? Why? Because these ions are so useful for us in many functions. For example, calcium is useful for muscle contraction. Sodium and chloride are useful for maintaining the osmolarity of our blood or making sure we can send signals through our neurons, okay? So they're very important for many reasons. So we don't want to get rid of all of them. We want to keep some. But at the same time, there are some ions such as potassium and hydrogen that we want to send back out into our tubules. We want to get rid of them from our bloodstream. So we send them out like this, you see? Now, why do we want to get rid of hydrogen? We want to get rid of hydrogen from our blood because if hydrogen builds up, our blood will be too acidic. Hydrogen is an ion that makes our pH very low. So if it gets too low, we could die. So it's important that we consistently pump out these hydrogen ions so that it doesn't build up and cause us to die. At the same time, potassium also needs to be pumped out, because if potassium builds up in our bloodstream, we could have severe problems with our neurons, because potassium, if you haven't learned yet, is related to our neurotransmitters. They're related to helping our neurons transmit signals, and if there's too much of this, we could have a problem with that and die. Okay, so a good way to remember what happens where is that the one-letter ions, so K and H, potassium and hydrogen, the one-letter ions, because they have one letter, they are pumped out of the blood into the tubules, whereas the two-letter ions, so these, so sodium, Na, Cl, and Ca, they are absorbed, so into the bloodstream, because we may need them. Okay, so this is it. So anything that remains at the end of the distal convoluted tubule will now travel into the collecting duct, and that's it. So I hope this made as much sense as possible, and just stay tuned for the next video. Then we're done with the kidney, and then I'll just make an overall summary video.